If you check the modern day data engineering job descriptions, you will find that almost every company mentions the cloud as a critical skill. This is but obvious, considering the fact that organizations are adopting cloud for all of their development needs, be it creating software or designing AI workflows. That's why, if you want to become an employable data engineer, you must prepare yourself for data engineering related cloud services. Azure Databricks is one of the most trending cloud services adopted by many organizations. If you've landed at this video, then chances are you already know the importance of Databricks and are preparing yourself to face Azure Databricks related questions. If that's the case, stay tuned till the end of this Azure Databricks interview question session. But before we do that, ensure that you subscribe to Intellipaat's YouTube channel and hit the bell icon to never miss any updates coming from our end.
Let's start with our set of Azure Data interview questions for beginners. Our first question is, what is Azure Databricks? Azure Databricks is a powerful platform provided by Microsoft Azure that helps you work with big data. It's like having a virtual space in the cloud where you can perform complex data analytics and processing tasks. I will give you an example. Imagine if you have a huge amount of data that you want to analyze to gain insights and make informed decisions. Azure Databricks simplifies this process by providing a user-friendly interface and set of tools specifically designed for big data tasks. With Azure Databricks, you can easily build and manage workflows for tasks like data cleaning, data transformation, and advanced data analysis. So, moving on to our next question, which is, what are the main components of Azure Databricks? The main components of Azure Databricks include collaborative workspace, managed infrastructure, Spark, Delta, MLflow, and SQL Analytics. So I will tell you one by one. First is collaborative workspace. It is a web-based interface where your team can collaborate on data projects. It offers tools for coding, data exploration, visualization, and many more to allow multiple users to work together efficiently. Then we have managed infrastructure. It is also a crucial component as it takes care of the underlying infrastructure for you. That includes server provisioning, storage management, and cluster configuration. Actually, this saves you from the hassle of setting up and managing the infrastructure so that you can focus on data analysis. Then we will see one of the core technologies powering Azure Databricks, which is Spark. It is an open source data processing and analytics engine that enables fast and distributed computing. It also supports various tasks like data transformation, advanced analytics, and machine learning. Moving on, we have Delta. It is a component that enhances data reliability and performance. It also provides efficient data storage and management capabilities. It is also used to handle large-scale datasets with ease. Moving on, we have MLflow. So what exactly is MLflow? It is an open source platform for managing the machine learning lifecycle. It helps data scientists track, manage, and reproduce experiments, as well as deploy and monitor machine learning models. In the last, we have SQL Analytics. Obviously, so from the name itself, you can see that it works on a powerful SQL queries, that your data uses a familiar SQL syntax. It also provides optimized query performance and seamless integration with other Azure services, making it easier to analyze and derive insights from the data using SQL based options. Now we have the next question, which is, what is reserved capacity in Azure? Azure Reserved Capacity offers discounted prices compared to pay-as-you-go pricing, allowing you to save money by committing upfront to a certain quantity of resources for 1 or 3 years. It works well for workloads that are predictable and is available for services including VMs, Azure SQL Database, and Cosmos DB. As you can see from the screen, the first case is in which there are two capacity instances which are present there, and both of the capacities are unused now. So max capacity is 2 and total virtual machines associated with these are 0. Then we have the second step. In particular, this step, you can see from the screen, we have now used one of the capacity as VM0 and the second one still remains unused. So we saw that capacity is still 2 and virtual machines associated is now 1. Moving on to the other instance. In this, basically the third step is an capacity which is repeat. It is a capacity which is over allocated state. At this point, you will start paying pay on the go over capacity reservation. Here you can see there are two capacity instances in the last, but in the first capacity there is two of the virtual machines present, VM0 and VM1, and in the second capacity we have VM2. So there are two capacity, but the total number of virtual machines associated is 3. So basically it is the last step of the reserved capacity in Azure. Moving on to our next question, which is describe the various components that make up Azure Synapse Analytics. So Azure Synapse Analytics sounds interesting, right? So what exactly it is? Azure Synapse Analytics act as a one-stop shop for your data analytics needs. So what are the following elements? The following elements are SQL Data Warehouse, Apache Spark, Azure Data Lake Storage, Azure Data Factory, and one of the most powerful BI tools, which is Power BI. So now we will see one by one. First one is SQL Data Warehouse. So what it is? Think of it as a giant scalable storage unit for your relational data, which allows you the fastest analysis. Then we have Apache Spark. It is a powerful house that handles complex data processing and machine learning tasks, especially for the big data set. Following up, we have Azure Data Lake Storage, which we also call as ADLS. It is a secure and endlessly growing lake to store all your data, structured or unstructured. Then we have Azure Data Factory. So what is Azure Data Factory? It is the conductor of a data symphony. ADF automates the flow of data between all these components which I mentioned above. Then in the last we have Power BI. As once your data is analyzed, so what exactly Power BI does is to transform it into beautiful and interactive dashboards for clear data storytelling. That's nice, right? So now we will move on to our next question, which is give some of the advantages of Azure Databricks. So obviously everything comes with the advantages and disadvantages. So here we will be discussing about the advantages of Azure Databricks. I have already mentioned the 4 advantages, which is collaborative environment, scalability, time to value, and security. So we will see all the advantages mentioned. So first is collaborative environment. It is basically that how a teamwork can make the task easy. Just imagine you have a central hub where data scientists are working together with the analyst. So what Databricks does is it provides you a collaboration of a shared workspace for everyone to contribute, share knowledge, and tackle projects efficiently. So that's how it can be called as a collaborative environment. Okay. So now we have scalability. So scalability is defined to any repeat. Basically, scalability is to mass your work to up to any challenge. Okay. So this advantage will tell you that massive data sets are no longer will be holding you back, as Databricks scales effortlessly to handle even the most demanding work. Whether you are dealing with terabytes of customer data or real-time sensor, Databricks delivers the processing power you need. Then we have time to value. So you should stop wasting your time building infrastructure from scratch, as Databricks offers pre-built templates and integrations that get you started quickly. This translates to faster time to value, allowing you to gain insights from the data and make data-driven decisions sooner. And in the last, we have security. So Databricks provide you the security you can trust, as it will protect your sensitive data, which is paramount. And it also prioritizes security with features like data encryption, network isolation, and granular access controls. So these 4 were the advantages of Azure Databricks. So moving on to our next question, which is what does autoscale mean in the context of Azure Databricks when it comes to cluster of nodes? So what exactly is autoscaling? Autoscaling refers to the ability of a cluster to automatically adjust the number of worker nodes based on the workload or the amount of data being processed. If the workload increases, the cluster can automatically add more worker nodes to handle the load. It is a diagram of a cluster autoscaling processes in Azure Databricks. The diagram shows you a grid of worker nodes, WN, which is mentioned in WN1, WN2, 3, 4, and 5, so on, which are connected together, okay? So these can be automatically added or removed based on the workload demands. The initial cluster state has only 3 worker nodes, WN1, WN2, and WN3. And after scaling up the cluster, it moved to WN5. So what it tells, Azure also can add more worker nodes to handle the processing and reduce the number of nodes when the workload decreases. So you can also see if the workload is less, the WN nodes can be reduced to 1 also. It can be happened both ways. Okay. So this helps you in optimizing resource allocation and cost efficiency. That is actually a very nice feature of Azure Databricks. Moving on to our next question, which is explain the function of Databricks file system. So the Databricks file system is a distributed file system that provides a unified storage layer for all the data in Azure Databricks. It allows users to easily access and share files across clusters, notebooks, and jobs, providing a scalable and reliable way to manage data for analytics and machine learning tasks. So, what is DBFS? It is a storage layer, okay? As you can see from the picture, in this system, there's a main leader called the driver, okay? Who starts and control the task. Then the jobs are split into the stages to do different parts of the work at the same time, which makes the things work more faster. First one we have executor. They are the colored boxes which get tasks from the driver and go to them all them together. As you can see from the screen, after the driver, it has been divided into three of the boxes, and all the three boxes have executors. So what are executors? They are the ones who get tasks from the driver and do them all together. Once each of the stage is done, it tells the driver the result. Then the driver can use those results to do more work. This way, a lot of tasks can be done at once across the cluster, making everything run smoothly and quickly. So basically, this is the function of the Databricks file system that helps you to lessen your workload on time. Next question we have is name different type of clusters present in Azure Databricks. So Databricks offers various cluster types to cater to different workloads. So we'll see what are the different type of clusters that will help you to choose the best fit. First one is single node clusters. Then we have multi-node clusters. After that, auto scaling clusters. Then we have high concurrency clusters, and in the end we have GPU enabled clusters. So that we will learn one by one. First we will have single node clusters. So these are ideal for beginners, okay? These small and one machine clusters are perfect for learning the ropes, testing code snippets, and prototyping simple data processing tasks. Then we have multi-node cluster. This is for the big data, alright? This is your go-to option for handling massive data sets, complex data analysis, and running intricate algorithms. Basically, this is the power of multiple machines to working together that enables efficient processing of large data volumes. Then we have automatic or auto scaling cluster. This is an dynamic option, first of all, which have multi-node cluster family, and it also adjusts their sizes based on the workload. When you have fluctuating processing demands, in this particular step, auto scaling clusters ensure that you have the resources that you need without manual intervention or without manual interference, and it also optimizes cost efficiency. Okay. Moving on, we have high concurrency cluster. Concurrency is the repetition. Okay. So collaboration is the key. Designed for shared use by multiple users, high concurrency clusters prioritize efficiently resource allocation to handle concurrent queries from various users without compromising performance. This is ideal for team-based data exploration and analysis, as we are sharing space in this and also working together. And in the end, we have GPU enabled cluster. So obviously, if GPU is mentioned here, so it is connected to the internet. So these clusters are specifically designed for computationally intensive workloads like machine learning and deep learning. The presence of GPUs accelerate these tasks significantly compared to the traditional CPUs. So let's see the next question, which is how does exactly Azure Databricks handle security? So this is one of the most important questions, okay? So exactly how Azure Databricks will help you in securing your data. So these are the following points. First one is Azure Active Directory integration. Then we have network security, roles-based access control, cluster isolation, data encryption, audit logging and monitoring, and secrets management. So we will see one by one. First one we have Azure Active Directory integration. So it also So it is a user access management which is achieved through. So basically, it is a user access management that is achieved through seamless integration with the Azure Active Directory. Okay. Basically, this eliminates the need for separate credentials for Databricks, as it allows users to sign in with their existential organizational identity. You can also term it as single sign-on (SSO), which further simplifies access and reduces the risk of unauthorized login attempts. As you have a single credential, so you will not have to put too much of values altogether. Then we have network security. So granular network control over network access is provided by the IP access. Administrators can define specific IP addresses or ranges that are allowed to access Databricks workspaces. So this particular security type restricts access attempts from the unauthorized locations, adding an additional layer of security. Then we have role-based access control, RBAC. It empowers administrators to define user permissions within the Databricks environment. This ensures that users only have access to the resources and functionalities that they need to perform in their tasks. So this is also a principle of least privilege minimizes potential damage in case of compromised accounts. Then we have cluster isolation. It is one of the network security policies that can be enforced by isolating workspaces within VMs or VNets, virtual networks basically. It creates a secure environment for your data processing tasks and also separate you from the public internet and other resources, right? Then we have data encryption. So data is protected both at rest and in transit through robust encryption. Robust is basically complete security. And Databricks encrypts data on disks using industry standard algorithms, and data transmissions are secured using TLS or SSL protocols. So it also ensures that even if any data breach is intercepted, your data remains unreadable. Okay. Then we have audit logging and monitoring. So it is basically a comprehensive audit logs that tracks all your user actions within the workspace. It also allows administrators to monitor activity and identify potential security breaches, or basically the suspicious behavior which is happening in your Databricks account. It also integrates with the Azure monitoring services that provide further insights into resource utilization and obviously the potential security threats that need to be happening in the future. And the last, we have secrets management. So it is a sensitive information like passwords or API keys that are used often within the notebook. This Databricks integrates with the Azure Key Vault, a secure store for all the managing these secrets. So these were the ways that how Azure Databricks handles your secure data. Repeat. So these were the ways how Azure Databricks handles your data in a secure. Next we have, what do you understand by the term control plane? The control plane refers to the management plane. Okay. So where the Databricks operates a workspace application and manages different type of things like configuration, notebooks, libraries and cluster. Basically in Databricks, the workspace application is used for managing notebooks, setups and clusters is located on the control plane, which also acts as the administration center. In the image you can see there are web applications, notebooks, job scheduling and cluster management. So what exactly are these? A web application is likely that represents the user interface or API through which users interact within the system. Okay. And in this, users also can submit data processing tasks such as configure settings and monitor the progress of their jobs also. Then we have job scheduling. So basically this component is responsible for managing the execution of data processing tasks. It receives job requests from the web application and it translates them into instructions for the data and schedules their execution also. Okay. So then we have cluster management. In this, serverless processing happens and it also eliminates manual cluster management, in which some implementations might have basic cluster management component, others could not have that. And it is also responsible for provisioning resources for stateful services or specific configurations that are required by some of the data processing tasks. So basically this was the control plane infrastructure in which different type of things were there, which I already explained now. So moving on to our next question. So now we have come to the Azure Databricks intermediate level interview question. So these are the questions which needs theoretical concepts as well as some practical knowledge also. So first one we have, which are some of the most important applications of Kafka in Azure Databricks. So Kafka is a Azure Databricks. Repeat. So basically Kafka is used to build real-time streamlining data pipelines and real-time streamlining applications also. So in this, a data pipeline is reliably processes and moves data from one system to another, and this is the one of the most important things that Kafka does. Okay, so the applications of Kafka in Azure Databricks include real-time data processing, data integration, event-driven architecture, and microservices communication. So the first one is real-time data processing. So as you can see from the name itself, it shows that you will get insights on real time. So what exactly it is? It is a process that streamlines data from Kafka almost instantly using Spark streaming. It also helps you to gain valuable insights from your data as it arrives, allowing you for faster decision making. Then we have data integration, or you can also call it as unified data pipeline, as it helps you to integrate data from various sources into Databricks using Kafka streams. This simplifies data ingestion and helps you to build secure and big data pipelines for comprehensive analysis. Then we have event-driven architecture. So it is basically a reactive architecture that responds swiftly to data changes and user interactions that are published through Kafka, Spark streaming in Databricks, and also can react to these events in real time. And in the last, we have microservices communication. Basically, in this, microservices has been made easy, and it also facilitates communication between independent microservices running on Databricks or other cloud platforms. This promotes modularity and scalability to your application. So by leveraging or using these all of the applications within Kafka and Azure Databricks together, you can build a powerful data processing environment that thrives on the real-time data. Next question we have: explain the difference between Azure Databricks and AWS Databricks. So both of them are very famous cloud service providers, and they are at ranking at 1 and 2 consecutively. So let's see the differences one by one. As first one is the cloud provider. For Azure Databricks, obviously the Microsoft Azure are the cloud providers, and for AWS Databricks, Amazon Web Services are responsible for that. And then we will see how they are integrated. So Azure Databricks is integrated with Azure services like Azure Data. So Azure Databricks is integrated with Azure services like ADLS, SQL DW, and more. So ADLS is Azure Data Lakehouse service, and SQL DW is SQL Data Warehouse, and many more. And then in AWS, it is integrated with services like S3, Redshift, Glue, AWS SageMaker, and many more. And then we will come to the security aspects. So Azure is integrated with Azure Active Directory for authentication, while on the other hand AWS is integrated with IAM for authentication and access control. And then we will see how they are different in machine learning, as Azure is integrated with Azure Machine Learning for ML workflows, while on the other hand AWS is integrated with ML tasks and model deployment. Okay. And in the last, we have to see how the tools are different for both of the cloud service providers. First one is integration with Azure Data Factory, Power Hub BI, and many more. So basically Azure is related or integrated to the Azure Data Factory, Power BI, and many more of the, while on the other hand AWS Databricks is integrated with AWS Glue, Athena, QuickSight, and many more. So these were the differences between Azure Databricks and AWS Databricks. Moving on to our next question, which is name the type of widgets used in Azure Databricks. As you can see from the screen, I have put 4 type of the widgets are available in Azure Databricks, which are text widgets, drop-down widgets, combo box widgets, and multi-select. So I will tell you one by one. So what exactly is text widgets? Basically they help you to make entering values into text fields easier. Then we have drop-down widgets. In this you can find a value from a list of preset values by using this type of widget. Then we have combo box widgets. This widget allows you to choose a value from a list or enter a value into the text. And you should also notice that this is the cross between the drop-down widgets and text widgets. And in the last we have multi-select widgets. From the name itself you can guess that this widget allows you to select numerous options from a list of values that are called multi-select widgets. So next question we have: how does Azure Databricks handle schema evolution in Delta table? What exactly is a Delta table? Any table that contains data saved in the Delta format is referred to as Delta table. On top of Apache Spark, these tables offer ACID properties. So what are ACID properties? Atomicity, consistency, isolation, and durability, right? So in this it is accomplished through automatic schema evolution, and in simplest form automatic schema evolution simplify that when new columns are inserted in the data, it does not need manual schema modification. As the schema progresses, current queries run well, and virus-like operating scheme changes are easily handled. It increases the flexibility and the speed of data pipelines while also allowing them to be customized to meet changing requirements. So basically this means that in this particular of Delta tables, you just have to start putting the values, and as far as the schema is getting progress, the current query is also running, then you don't have to put any manual interference between the process. As you can see from the picture, in the first process as employee name and employee ID, which is Mitesh and Tiwari, 1093 and 1085. As I already told, as the schema progresses, you don't have to put that manual interference, as it itself will start putting the values and adding the new columns. Like here it added identity column, and it also told that Mitesh is working in HR department and Tiwari is working in marketing department, right? So this is how Databricks handles schema evolution in Delta tables. Okay, so moving on to our next question, which is explain the concept of table caching in Azure Data. So what is table caching anyway? So table caching in Azure Databricks is like keeping a quick access copy of a table or data in the computer's memory. So basically your data or your table is getting stored in the computer memory as a reference for, so that will help you in getting your data searched and analyzed much faster, because it is not constantly read from the storage. Basically it's like having a reference cheat sheet. So basically you are having a reference cheat sheet to speed up time consuming tasks like sorting, finding, and performing calculations. So as you can see from the screen, we have the database, and there are two instances, application instance A, application instance A. So basically these are the shared cache service. Okay, so in this, the identical cache data is visible to both application instances. So basically the two instances are identical, that's why the name of the instances are same. So the first instance is the copy of your data, and the second is basically the data which you only have put for the storage. So this is how the table caching works. One data you already put from your side, and the second one is created as the copy of your result. Okay, so this is how the concept of table caching in Azure Databricks works. And then we have how to explain Azure Data Lakehouse and Data Lake. So first one we have data warehouse, then we have data lake, and then we have data lakehouse. So these all three are connected to each other. Okay, and Azure Data Lakehouse combines the features of a data lake with the capabilities of data warehouse. Okay, so as you can see from the screen, the Azure Data Lakehouse is in the most right corner, and the Azure Data Warehouse is in the most left corner. So it offers a single scalable platform for storing and managing both structured and unstructured data, bridging the gap between traditional data warehouses and data lakes. So data lake has the features like ACID, okay? So atomicity, consistency, isolation, durability. And these are the transactions, indexing, and schema enforcement also are present with the Azure Data Lakehouse. And it is designed for big data analytics applications. Azure Data Lake is highly scalable secure data storage solution offered by Microsoft Azure. Large volumes of both organized and unstructured data can be stored by businesses in their original format. High productivity, smooth access control, and interaction with several analytics and data processing services are just few of the benefits that Azure Data Lake provides. So basically the Azure Data Lakehouse is combination of data warehouse and data lake. In the data warehouse, only structured data is present along with the tools like BI and reports. But in data lake, there are structured, semi-structured or unstructured data is also present, which includes data science models, then machine learning models, also the ETL models and warehouses. So basically, if you will combine data warehouse and data lake, you will get data lakehouse. So it also contains structured, semi-structured, or unstructured data, along with the power of data warehouse as well, as it has a layer called moderate and governance layer, which acts as a bridge between data warehouse and data lake, and it gets combined to all the machine learning models or the data science models, which further explains that how Azure Data Lakehouse and Data Lake are connected to each other. So now we are moving to our next question, which is what is the difference between a data warehouse and a data lake? So just before we got to know what exactly is data warehouse and data lake, so let's see what are the differences exactly. Okay, so the first aspect is data type. So data warehouse has only structured data. It doesn't have the unstructured or the semi-structured one, while the data lake has structured, semi-structured, unstructured data all together. Then what exactly is schema? So how it exactly works? So data warehouse is a schema on write, like it is a rigid schema enforced before storage, while the data lake has schema on read, which provides you flexibility as it is applied when reading the data. So then we will see the processing speed. So data warehouse is optimized for high speed, ready, heavy work. So it will carry out heavy workloads in faster time. While data lake is flexible and can handle batch, streaming and ad hoc processing. Then we will see how they are different in data storage. Data warehouse has normalized and structured storage, while on the other hand, data lake has raw as is storage preserving original data format. Basically, whatever data you store in data lake is it present in the original data form. So it gives the authenticity to your data. And in the last, we have the cost, how they are different in the costing or pricing. So data warehouse is usually higher due to a structured and indexed storage, while the data lake is often lower due to storage optimization and flexible schema. So these were the differences between data warehouse and data lake. Moving on to our next question, which is what is serverless database processing? I have mentioned this picture over the screen. As you can see, there are different types of data sources, AWS services, then we have other services as well. So I will tell you one by one how the serverless database processing works. So now I will give you an explanation of the components in relation to serverless database processing. So first we have data sources as IoT sensor. So what exactly are IoT sensors? So the system that can ingest data from various Internet of Things sensors. So basically, this data can be represent temperature readings, machine logs, or any sensor measurements relevant to your application. So basically, IoT sensors is used to capture temperature readings or machine log, which further tells about AWS services. So AWS services, there are many type of AWS services which are present in the serverless database processing, such as Amazon Kinesis Forehouse, AWS Lambda, Amazon DynamoDB, Amazon Kinesis Data Analytics. Then we have Amazon Kinesis Data Streams, and in the end we have Amazon S3 and Amazon SNS. So these all are present in the serverless database processing. We will start with the Amazon Kinesis. So you can see from the screen there is a Firehose delivery system which directly sends data to Kinesis Analytics, which is famous for anomaly detection. So basically this service acts as a streamlining data ingestion channel that captures raw data from the IoT sensors present in the screen and delivers it to the other AWS services for further processing. As you will see, the process number 1, it has IoT sensors, and then 2 is Firehose delivery system. So basically from 1 to 2, the data has been transferred in the raw. So there is a Lambda over there which is called AWS Lambda. In this, the serverless compute service that plays a central role in processing the data stream. So basically what Lambda does is here that Lambda functions basically are the small pieces of code that are designed to perform specific tasks. In this context, Lambda function likely performs transformations on the raw sensor data such as filtering or reformatting. And then it goes to DynamoDB. It is a NoSQL database service that can store the process data from the Lambda function. Okay, so it is also a very good fit for schema-less data or the data with constantly evolving structures, or basically a structure which keeps changing according to the requirement. Then we'll come to the level 2 as well. In this, Lambda is also present there to more filter out the data. And in third, then we have Amazon S3, in which buffered files are present. Basically, what exactly is Amazon S3? Amazon S3 is a managed service, or you can say is an object storage service that can be used for storing archived or buffered data. So in this particular architecture, it might hold process data from DynamoDB for later retrieval or analysis, as it is also connected to DynamoDB. So it will also store the data from DynamoDB for later retrieval or analysis if it is needed. And then it goes to Kinesis Analytics, or you can call it as anomaly scores. Then it goes to data streams, alerting, and SMS alerts. So what is data streams? So data streams is a managed service that facilitates continuous data ingestion from various sources like Kinesis Forehouse, which is on level 2, and then it goes straightly to Kinesis services, which acts as a buffer for streaming data and allows the data for further processing or storage. And in the end, we have Amazon SNS, which is mentioned as SMS alerts. So basically it is a messaging service that enables notifications based on events in the data stream. SNS can be integrated within the system to trigger alerts or notification based on anomalies detected during data processing, because Kinesis Analytics is present over there to detect anomaly. And if it is detected, SNS will send an SMS alert to the server telling that anomalies have been detected. So this was how serverless database processing works. So moving on to our next question, which is, what are PySpark data frames? So in Apache Spark, PySpark data frames are distributed collections of data organized into named columns similar to traditional tables in databases or spreadsheets. So there are many key characteristics which are present, but some of them are here which I have mentioned. There are distributed, structured, and lazy evaluation. So what is distributed data frame? It is a data frame in which data is stored and processed in parallel across multiple nodes that enables you to handle massive data sets that wouldn't fit on a single machine. Then we have structured. In this, data is organized with the rows and named columns, each containing a specific data type like integer, string, or date. And in this structure makes it easier to manipulate and analyze data. And in the last, we have lazy evaluation. So basically, operations on data frames are not immediately executed, right? But rather it is defined in a logical plan. So when an action happens, or like if suppose action is like displaying results, evaluation gets triggered, and the plan is to optimize and execute it efficiently. So moving on to our next question, which is what are dedicated SQL pools? So dedicated SQL pools are separate compute resource for running SQL queries in Azure Databricks. So they are very useful for the queries that don't require the full power of Databricks cluster. As you can see from the screen, we have compute nodes, which is further connected to massively parallel processing engine and then further to Azure storage. So then now we have come to our last level of interview questions, which is advanced level of interview questions. Let's start with our set of Azure data interview questions for beginners and then further to Azure storage. Then now we have come to our Azure Databricks advanced level interview questions, and let's see what are those. First one is, what are the different applications of table storage that are present in Microsoft Azure? So there are many applications of table storage. First one is keeping structured data. Then we have web applications. Then we have Internet of Things and sensor data analytics. And then we have analytics and logging. And in the end, we have backup and disaster recovery. So first we will start with the keeping structured data. So it basically means that structured data has the freedom, or structured data is like user preferences, product catalogs, or customer information that without the rigidity of a fixed schema. So this flexibility caters to evolving data. And then we have web applications, which tells you about the web app efficiency that this application provides. So powerful web applications with fast and easy access to large data volume. These track users' behavior, store sessions data, and manages user profiles efficiently. And then we have IoT and sensor data, which tells you that it seamlessly handles sensor and IoT data. From temperature readings to GPS locations, it has got you covered. Table storage offers a scalable solution for diverse device data. Then we have analytics and login powerhouse. So it analyzes large data sets and centralizes log data. Application logs, web visitor data, and performance metrics can all be stored for deeper insights in this particular type of application. And in the last, we have disaster recovery backup that ensures your critical data is secure and safe. You can use table to store, create backup that safeguard your information in case of any emergency. So table storage goes beyond traditional databases by providing you a flexible and scalable foundation for various storage data you need. So moving on to our next question, which is, how does Azure handle redundant storage of data? So to guarantee that the data is always available and accessible, Azure keeps several copies of data stored at various levels. Numerous data redundancy techniques are available in Azure storage facilities that guarantees data security and availability. So I have mentioned 4 of the techniques. Let's see how they work. First one is locally redundant storage, or LRS. In this, Azure copies data across several storage areas stored within the same data center to maintain highly accessible data. It is also known as locally redundant storage since the data copies are kept in 3 separate locations inside the same physical space. Then we have zone redundant storage. Storage data is replicated to 3 different availability zones of the primary zone. In this, you can make sure that the data can be recovered from the copies kept at these edges if the original site is inaccessible. Then we have GRS and RAGRS. So what is GRS? GRS means geographical redundant storage. In this, data redundancy option is offered by Azure if the entire region experiences a power failure. So data copies are kept at 2 or more different sites spread across various geographic areas. If the primary site is unavailable, accessing data from the secondary location requires a geo failover. And in the last, we have read access geo redundant storage, also told as RAGRS. When the primary region goes down, this data redundancy option makes sure that data saved in the secondary region is still accessible. So basically, RAGRS is a backup of GRS. So this is how Azure handles redundant storage of data. Moving on to our next question, which is, how CI/CD is achieved in the case of Azure Databricks. So basically in this process, there are 3 stages which are involved. First one is development, then we have continuous integration, and then we have continuous deployment. So first we will see the development stage. In this, developers use automated pipelines and Databricks jobs for continuous integration. So in this particular process, Azure Databricks is usually accomplished by combining techniques and technologies specific to data engineering and analytics workflows. As developers develop the code, then it commits the code to the GitHub, and they also get notified as their code is committed. First of all, developers keep track of changes to their code and notebooks using version control systems like, as I already mentioned, GitHub, which guarantees that modifications are monitored, discussed, and cancelled as per the need. Then the continuous integration comes as developers use automated pipelines and Databricks jobs for CI. To ensure that the code is integrated regularly, these tasks can be programmed to execute automatically each time as the changes are pushed to the repository. It also used to preserve data quality as these pipelines can incorporate tests such as integrity checks and data validation. So basically, this is how you should build pipeline. As the first step should be to check out if the code has been changed, and then you have to trigger the test, and if the test is cleared you have to pull the test results as well. In the second step this happens. So let's go to the third step, which is continuous deployment, as it is facilitated by using Databricks notebooks and jobs within deployment pipeline. Code updates are automatically deployed to production or staging environments after they pass integration testing. These deployments can be coordinated by Azure DevOps or the other CI/CD platforms, which we will start the required Databricks jobs or notebooks. In this, we have to release the pipelines, which is updated with the released code, and it goes beyond the boundaries. So moving on to the next question, we have which kind of consistency models are supported by Cosmos DB. So Azure Cosmos DB offers different consistency levels to cater to different needs. Before that, we need to know what exactly is Cosmos DB. So basically, Cosmos DB simplifies and expedites your application development by being the single database for your operational data. From caching up to backup to vector search, everything is covered under the Cosmos DB. So what are the different consistency levels in this? There are 5 types of consistency levels, which are strong, bounded stainless, session, consistent prefix, and eventual. So let's see it one by one. First one is strongest consistency. That ensures that all the replicas or the copy ones have the same data at all times, providing the highest level of consistency. Then we have bounded stainless that allows a slight delay in propagating changes, striking a balance between consistency and availability. After that, session consistency guarantees that the consistency within a single session, ensuring that subsequent reads or writes within the same session to see the latest data. And then we have consistent prefix consistency that ensures a consistent ordering of data even if not all replicas are fully synchronized. And in the last, we have eventual consistency that allows replicas to converge to a consistent state over time. These consistency levels allows users to choose the right trade-off between consistency and performance based on their specific requirements and use cases in Azure Cosmos DB. And then we have how to describe the process of creating a Databricks workspace in Azure. So there are few steps that how this process works. For that step, I have put a snapshot of the process and I will be explaining how exactly you have to do that. For that, you have to first click on the workspace tile in your account console. After that, you have to click on quick start option when you click the create workspace drop down. As you can see in this picture, just nearby the virtual network box we have as Databricks quick start, and then we have to enter the following on the let's setup on your workplace page, and a workspace name that's easy to use. You have to write any of the name which is very easy and accessible for you so that you don't forget in future. And then you have to click on the AWS region in which you have to wish to host your Databricks workspace, and after that you have to click on start quick start and enter the password for your Databricks account, and keep in your mind that you should not forget your Databricks password. Then and next step will be to review the workspace that is being generated. After that, you have to click create stack to open the Databricks workspace stack page. And once the Databricks workspace has been created, it will indicate as create complete that you have to click on that and workspace dashboard in the Databricks account console to access your newly created workspace. And then you have to start your own workspace by clicking open next to the newly created workspace, and in the end you have to click on finish after making a principal use case selection. So these were the few steps that goes under the process of creating a Databricks workspace in Azure. Moving on to our next question, which is discuss strategies for seamlessly integrating Azure Databricks with other Azure services. So I have figured out two of the Azure services that is seamlessly integrated with the Azure Databricks. First one is Azure Data Lake Storage and second one is Azure Synapse Analytics. Azure Databricks integrates tightly with other Azure services to create a robust and unified environment for your data processing pipeline. So here's a breakdown of strategies for seamless integration with three key services. First one is Azure Data Lake Storage. It has options like storage for raw and processed data, mount ADLS in Databricks, and data lake on ADLS. So what is storage for raw and processed data? Basically, it uses ADLS Gen 2 as primary storage for your raw data and the landing zone for processed data from the Databricks notebook. Then mount ADLS is within your Databricks workspace that uses notebooks or the Databricks UI. It allows you to access and process data directly from ADLS without manual data movement. Then in the Delta Lake, you can leverage Delta Lake, which is built on the top of ADLS and is used for reliable data storage with AC transactions and schema evolution capabilities. Moving on, we have Azure Synapse Analytics, in which complementary services are the services that utilizes Azure Synapse Analytics for large-scale data warehousing and serverless data exploration. It uses Databricks for complex data transformations and advanced analytics requiring Apache Spark processing power. Then we have data sharing with managed external tables. In this, the data has been created managed external tables in Synapse Analytics pointing to data stored in ADLS. This allows you to seamlessly query data processed by Databricks within the Synapse Analytics environment. And in the last, we have orchestration with Azure Data Factory. In this, you can utilize Azure Data Factory to orchestrate your data processing pipeline. And an Azure Data Factory can trigger Databricks notebooks and integrate them with the other data processing activities in Synapse Analytics. So these were the few strategies for seamlessly integrating Azure Databricks, few of the other Azure services. So the next question is, how is data encryption handled by the ADLS Gen 2? So ADLS Gen 2 can be handled in many ways. So first of all, it offers three different authentication mechanisms to guarantee that user accounts are maintained securely through Azure Active Directory, shared key, and shared access token. So ACLs and roles provide more precise control over who has access to specific folders and files. And networks can be separated when administrators choose which IP addresses or VPNs to permit or prohibit traffic from. And in the last, it will protect your sensitive data by encrypting it while it is being transferred over HTTPS. So these are the few ways how data encryption is being handled by the ADLS Gen 2. So this is one of the scenario based questions which I have put for giving you more practical knowledge. So what exactly is the question? Your organization needs to securely share sensitive data stored in Delta tables within Azure Databricks with external collaborators. Outline the steps you would take to set up secure data sharing while ensuring data privacy and compliance with regulation. So I have mentioned few of the steps as below. First step will be to ensure secure and compliant data processing, and I will create an Azure Databricks workspace, structure data tables with access controls, and will set up Azure Key Vault for encryption of data at rest and in transit. For secure data sharing, I will use Azure Databricks access control that lets me grant external collaborators to read or write permissions to specific Delta tables. To further safeguard my privacy, I will implement data mask and anonymization techniques within the Delta tables. This will help protect personally identifiable information while still allowing collaborators to work with the relevant data I have put on. Then in the last, I will do the regular auditing and monitoring of data access logs using Azure Monitor and Azure Security Center that will ensure compliance and regulations like GDPR or HIPAA. So these are the few steps that I will take to set up secure data sharing while ensuring data privacy and compilation with regulations also has been. So moving on to our next scenario based question, which is, your team is building a CI/CD pipeline for deploying machine learning models trained in Azure Databricks. Describe the steps involved in automating the training, testing, and deployment of models, ensuring reproducibility and version control. So basically, this data science pipeline automates model creation in Databricks. Data lands in the Databricks file system, then Notebook trains the model with fixed seeds and version control. Unit tests ensure performance against baselines, and successful models are saved in a versioned MLflow registry. In this, version flow tracks everything, and CI/CD tools orchestrate automated deployments based on the code changes. So first, we will establish the pipeline, and we'll start with the data ingestion into Azure Databricks. And using the Azure Data Factory or the similar tools like that, we automate data extraction from sources into Databricks Distributed File System (DBFS). Next, we will set up notebooks for model training, and we will ensure that reproducibility by fixing the random seed and version controlling the code using Git. For testing purpose, we will integrate unit tests within the notebooks to validate model performance metrics against historical baseline. Upon successful testing, we will automate the model deployment, which involves saving the trained model in an MLflow model registry within the Databricks, which allows versioning and easy retrieval. So throughout this process, we will maintain a version control for notebooks and models. Finally, we use Azure DevOps or similar CI/CD tool to orchestrate the pipeline, triggering automated runs triggered by code commits and ensuring seamless and efficient deployment. So these are the steps involved in automating the training, testing and deployment of models mentioned below. So moving on to our last question of this video, which is you are working on a project that requires complex data transformations and feature engineering on large scale data sets. Discuss the techniques and functions available in Azure Databricks to perform these advanced transactions efficiently. So first I will give you the summary, then I will tell you in brief. So the summary is that in Azure Databricks, I will leverage Spark's data frame API and user-defined functions for complex data transformations, which are used for large data sets. Then I will go for advanced techniques like window functions and MATLAB tools like vector assembler, transformers that enables feature engineering. And in the last, I will use Delta Lake integration that will ensure my data consistency. And also this powerful suite allows me to efficiently handle intricate data tasks. So in Azure Databricks, I will use several powerful techniques for complex data transformations and feature engineering on large data sets. First, I will rely on Spark's data frame API, which offers functions like with column, filter, and group by for efficient data manipulation. For more advanced transformations, I will employ user-defined functions that will enable custom logic on rows or columns. Windows functions are also crucial, aiding in calculations across rows within specified windows. Additionally, Databricks provide ML library for feature extraction and transformation tasks such as vector assembler I already mentioned. And then the Delta Lake integration will help me manage data versioning that will ensure the consistency and reliability throughout the transformations. So these tools will combine with Databricks scalable architecture will help me to tackle intricate data tasks efficiently and with confidence. I hope this video has provided you with valuable insights into Azure Databricks interview questions. We have also focused on important components such as collaborative workspace, managed infrastructure, Spark, Delta, MLflow, and many more. Understanding these components is crucial for successfully working with Azure Databricks and tackling interview questions effectively. Throughout the video, I have tried to share valuable tips and strategies, emphasizing the significance of hands-on experience with Azure Databricks and showcasing real-world project examples. Covering these questions will help you acing in your interview and will boost your confidence to face the challenges very well. So that's all we have for this video. If you found it helpful, then do share it with your fellow mates, and also don't forget to subscribe to our Intellipaat YouTube channel for regular updates like these.